Hi, Mr. Richards here, and today's lesson is on elimination using multiplication. Our objective is to solve systems of equations by using elimination with multiplication and to solve real-world problems involving systems of equations. And our key concept today, solving by elimination with multiplication, is very similar to solving with elimination using addition or subtraction. But we still have three steps. And our first step is to multiply at least one equation by a constant to get two equations that contain opposite terms. Then step 2, add the equations, eliminating one variable. Then solve the equation. And for step 3, substitute the value from step 2 into one of the equations and solve for the other variable. Write the solution as an ordered pair. If I had to summarize these three steps, think back to your elimination using addition, where you're just able to add and cancel out one of the two variables. Well, the equations today, the systems of equations today, you're going to have to work using multiplication in order to get things that cancel out. Let's take a look at what this looks like. Here we have 2x plus y equals 23, and 3x plus 2y equals 37. Now there's a couple different options here in how to solve this. We need to either get our x's or our y's as opposite terms, so one of the two will cancel out. And as I look here, I have a 2 and a 3, and I have a 1 and a 2. I think the y's are going to be easier to eliminate. So if I rewrite this as 2x plus y equals 23, and 3x plus 2y equals 37, what I'm going to do here is multiply this y by negative 2. In fact, I'm going to multiply each term in this first equation by negative 2. So that changes that equation. If I multiply everything here by negative 2, we get negative 4x minus 2y equals negative 46. And we still have our second equation unchanged at 3x plus 2y equals 37. Now what we can do is add. Negative 4x plus 3x is negative 1x, or just negative x. Then these get eliminated. And negative 46 plus 37 is negative 9. Now be careful, we have a negative 1x or negative x. We need to divide by negative 1 on both sides here. And our final answer is going to be x equals 9. Well, not our final answer, but at least for this step. X equals a positive 9. Now we need to pick one of the two equations to put in x equals 9 so we can solve for y. And I'm going to pick the first equation, 2x plus y equals 23. We'll substitute that 9 back in. 2 times 9 plus y equals 23. 2 times 9 is 18 plus y equals 23. Then subtract the 18 from both sides. We get cancellation, and y equals 5. And the last part here is to write this as an ordered pair. X goes first, so 9, 5. And there is now my final answer. So when we take a look at what we did, we needed to multiply our top equation here by -2 so that when I added the two equations together, we get elimination. And then we solve it just like elimination with addition. We just have that extra step this time. Now we can take a look at a systems of equations where we need to multiply both equations to eliminate a variable. We have 4x plus 3y equals 8 and 3x minus 5y equals -23. Now let's rewrite these here just to give ourselves a little bit more room. 4x plus 3y equals 8 and 3x minus 5y equals -23. Now how can we recognize that we need to multiply both equations? Well, unlike the first example, there's not a single number that I can multiply anything in my bottom row to eliminate anything in the top. I need to multiply both. There's actually two methods here. You can either eliminate the x or you can eliminate the y. And in this first try, we'll go to eliminate the x. Well, how can I do that? Well, let's multiply the top by 3. And if I multiply the top by 3, and if I multiply the bottom equation by -4, that gives me 12x plus 9y equals 24 if I multiply each term by 3. When I multiply each term by -4, 3 times -4 is -12x plus 20y, since a negative times a negative is positive, equals a positive 92. As -23 times -4 is 92. Now if I look here to add 12x plus a -12x, well, that eliminates, that goes away. 9y plus 20y is 29y equals 116. And when I divide now by 29 on both sides, I get my final answer, for y at least, of y equals 4. Now, could you have multiplied by a -3 on top and a +4 on the bottom? Sure. Again, our goal here was to try to eliminate the x's, so one of these had to be positive and one had to be negative. It doesn't matter whether you do -3 here and -4 there, or the other way around as we did. Now, if you pick one of the two original equations, let's pick the one where they're all positive. Might be more simple. 4x plus 3y equals 8. Substitute in your 4 for y. You get 4x plus 3 times 4 equals 8. 4x plus 12 equals 8. Subtract that 12 from both sides. 4x equals -4. Divide by the 4 to isolate your x. and x equals -1. Remember to always write these as an ordered pair. Our x goes first, -1, comma 4. And that is our answer. Now there is a way to check these. If you pick the first equation, say 4x plus 3y equals 8, and you substitute in -1 for x and 4 for y, 4 times -1 plus 3 times 4, that should equal 8. And does it? Well, -4 plus 12 should equal 8, and sure enough, 8 equals 8. So there is a way, just like when we're solving regular one-step, two-step, and multi-step equations, to also check our answers for systems of equations. Now, this example looks exactly the same, and in fact it is, but we're going to practice our method to eliminate the y. And if we rewrite this, 4x plus 3y equals 8, and 3x minus 5y equals -23. Now, one of these terms are already negative, so we don't need to worry about multiplying one by a positive, one by a negative, because if we multiply both by a positive, it'll naturally cancel. Now, what positive number? Well, this is a 3 and this is a 5, so I would switch that. I would multiply my top equation by 5, and I would multiply the bottom equation by 3. And a result there? Well, 5 times 4x is 20x. 3 times 5 is plus 15y. And 8 times 5 is 40. Then 3 times 3x for the second equation is 9x. 3 times a -5y is minus 15y. And 3 times -23 is -69. Now, if we look to add these equations together, 20x plus 9x is 29x. The plus 15y minus 15y eliminates, and 40 minus 69 is -29. And if I simply divide now by 29 on both sides to isolate my x equals -1. Pick an equation to solve. I'll pick the first one since they're all positives, and again, positives could be easier to work with than some of the negatives. Put in the -1 for x. 4 times -1 is -4. You can add the 4 on both sides to start to isolate the y. -4 plus 4 cancels, and you're left with 3y equals 12. Divide by 3 on both sides. And y equals 4 again. And again, -1, 4 is our solution, written as an ordered pair. So whether you choose to eliminate your x, or if you choose to eliminate your y, you should get the same answer. And on homework questions, all you need to worry about is eliminating one of the variables. These are just two methods. You get to pick whether you want to eliminate the x or if you want to eliminate the y. Now for our word problem. A fishing boat travels 10 miles downstream in 30 minutes. The return trip takes the boat 40 minutes. Find the rate in miles per hour of the boat in still water. Well, let's just calculate for now in minutes, and we'll convert to hours at the very end. We need to define our variables first. And so if I define my S as still water speed, the speed the boat would be in still water. And if I define C as the current, my rate with the current then would be the rate it would be in still water, S, plus the current. So the speed in still water plus the current. My time here was 30 minutes, so we'll just write it as 30. My distance was 10 miles. Now, and for my rate times time equals distance, just write my rate was, in parentheses, s plus c times my 30 is going to equal my distance of 10. Now, what about against the current? Well, it would be our speed in still water, s, minus the current, since we're going against the current. My time here was 40 minutes, and my distance was the same 10 miles. So to write this as rate times distance, or rate times time equals distance, we would have s minus c, my rate, times my time, 40, is going to equal my distance of 10. And there I have my two equations. The first one, s plus c times 30 equals 10. And the second one, s minus c times 40 equals 10. Now let's go ahead and use distributive property here. It's almost like backwards distributive, well, or distributing to the left. We would have 30s plus 30c equals 10. And 40s minus 40c equals 10. And now we need to use multiplication to eliminate. So if I multiply, well, what do we want to eliminate first? We're looking for the still water speed. We're looking to solve for s. So let's eliminate c. So if I multiply this top equation by 4 and the bottom equation by 3, I would have 120s plus 120c equals 40. Multiply the bottom equation by 3, I would have 120s minus 120c equals 30. Well, 120s plus 120s is 240s. The c's eliminate, the current eliminates, which is good, equals 70. And if I divide by 240 on both sides, I get this s to equal 0.2916 with that 6 repeating. Now, remember, this is now miles per minute. If I multiply by 60 minutes in an hour, I would get 17.5 miles per hour. And that's our final answer. Now, another option here is to take your 30 and use it as a 1/2, and your 40 minutes to use it as be 4/6 or 2/3 of an hour, and multiply that with your time. But this way works as well. That's it for this lesson. Good luck.